I figured, hey, we'll go over that topic. It's not just that I like this topic, because I do, but this one's going to show its head a lot next year, so you guys need to get used to doing this, okay? So the first task was to graph the line y equals negative 2x plus 3. And how have we learned to do that? What has been our chosen strategy? You remember?
Don't you make like the X and Y chart?
We'll make all right, some people call it a T-chart. I just call it a table. It's a table of values. It's a table of values that you choose for X, and then you find the corresponding or the matching Y values. Okay, that's why they're called coordinate pairs. One is paired up with the other to show the relationship. This is the algebraic representation. This is the tabular representation. And of course, the pictorial is a graph. Okay, and we'll do that down here. Okay, but before we can actually get to what it looks like, we have to use some values for X. And it doesn't matter what numbers you choose for X. Okay, but my advice again has been choose a negative, a positive, and 0. So we'll do negative 1, 0, and 2. Any negative will work. 0 is 0. Any positive will work. If you did all positives, that would work too. But I'm telling you to do the 0 to help you for the future. Okay? So what that looks like, how do we get the corresponding values? We're going to say, well, I'm going to plug in that number for X, so negative 2x plus 3. So I've got negative 2 times negative 1 plus 3. That's going to be 5. Right? I substituted in this value for X. This is the corresponding Y value. So said another way, there's some synonyms here. Input, output. Input, and what would be the matching output for 0? Negative 2 times 0 is 0, plus 3 is 3. Negative 2 times 2, an input of 2. Negative 2 times 2 is negative 4, plus 3, negative 1. So what I've done now, I have my set of points. I have 3 points, and that's why I told some of you on your homework and the recap, you need to have points. You can't just have a random line drawn that looks like what it might have looked like if you typed it into a graphing calculator or Google or something along those lines, okay? Along those lines, get it? All right, so negative 1, 5 is our first point. We'll plot that one. How do I move to plot the point negative 1, 5? I move left 1 and up 5. Okay. 0, 3. Well, I don't move any left or right, so 0 and then up 3. 0, 3. All right, that one's not very easily identified, okay. And then 2, negative 1. Right 2, down 1. Right 2, down 1. Yellow. Connect the dots, and voila, I lost my straight edge. This will have to do. So when you do this, remember it is a line, and by definition, line continues forever in both directions. It's not a segment, it's not a ray, it's a line. Okay? That is the secondary reminder that there's an infinite number of points along this line. Probably wouldn't consider it, but if you chose a number like 1.25, you could plug that in for X and get a corresponding Y value. Equally as decimally. That's not a word. But anyways, you could choose any number for X, plug it in, and get a corresponding Y. As you progress in your math career, there will be limitations on the X's you can plug in. Okay? There will be limitations. But for now, let's just think about it for a second. We haven't learned about the rules about why this line has a pattern that you'll see next year. Okay? But we've learned that the graph is just a picture representation of an equation. The table right now is that middle ground that helps us find those things. Now, second part of this warm-up is this point on the graph. What do you think? Did you guys answer that yet? 5 comma negative 13. Do you want a second to think about it since you've seen me go back over the process for using the table? I can't tell if that's your thinking face or not. So, what can we do to answer this? What do you mean?
Like kind of do what we did above and below. Like make another table.
Tell me more. What does that look like when I start? I don't need to make a new table, do I?
Make another.
What can I do with 5 comma negative 13? Assuming this could be on the graph, what does the 5 represent?
X.
Yeah, good. It's an X. And what does the negative 13 represent?
Y.
Yeah. So, what I can do is like a little math experiment. Suppose X is 5. So if X is 5, I'm basically just listening to Jeffrey right now. Let's continue our table. If X is 5 and Y is going to be the negative 2 times X plus 3, let's see if we get negative 13. So negative 2 times 5 plus 3. Is that going to give me 13? If it is, then this point is on the graph. If it isn't, then this point is not on the graph. So negative 2 times 5.
Negative 10.
Negative 10 plus 3.
Negative 13.
No. All right. I chose negative 13 on purpose. Negative 10 plus 3. Some people will say, oh yeah, that's negative 13. Because they forget. Negative 10, positive 3, they're on opposing teams. They're going to combat each other. So that's actually going to be negative 7, right? Negative 10 plus 3 is negative 7. Therefore, when X equals 5, Y equals negative 7. So the point 5, negative 7 would be on the graph, not 5, negative 13. And as you'll also learn next year, there's something called a function. Let me just give it to you in simple science fiction terms. That's kind of silly, say. If this point is supposedly on a graph and it's 5, negative 7, and the same line has a point 5, negative 13, how can that be true? How can that be possible for you to be able to plug in the same number and get two different answers? In math class, have you ever answered a question such as 4 plus 1 and there be two possible correct answers? No, because you can't be in two places at once. How does that connect? So, you'll see. I don't want to cloud your mind with other things of the future. Not the distant future. It's really coming next year. But all that to say this. Only one of these could exist on the graph. Okay? Because when you plug in 5, you have to get an answer. A single answer. All right. Let's go to homework questions from the book before we take a look at the test review. Okay? So, were there some homework problems that stuck out to you that gave you difficulty? Looking back through those, make sure I get those answered. I didn't see a whole lot of question marks, but I want to make sure I ask. Otherwise, we'll spend the rest of our time going over this test review. I got to do it twice. No questions? All right. So I'm going to have the answers up here for the first page. If you guys would get that out, let's go ahead and take a look. And I'm going to talk about where these came from. Don't worry. I want to talk about where this came from. Although, you should have a pretty good idea based on what we just did for the warm-up. Okay? So as Jeffrey mentioned, our strategy here in Algebra Half is to make a table, a T-chart, an input, output, whatever. Okay? Pick some numbers. Pick some numbers for X. Now you can look clearly and see that I have points on my graph. If you don't have at least 2 points, I'm not going to give you full credit on Thursday. Okay? You've got to have points labeled. They don't have to be the same ones as mine, but your graph would have to include those, so they'd have to go through there, okay? So I just plotted all 7 of those just for your benefit, but our strategy has been, hey, let's pick 3 numbers for x. Let's do -2, 0, and how about 3, okay? So when
Are we supposed to plot all those?
No.
Okay.
What I was saying is you just have to have 3.
Okay.
Any 3 out of these. Okay? Any 3. What I hope you're thinking about is it doesn't take 3 points. It actually only takes 2. If the line is a line, and by definition a line is straight, so when you say straight line, that's, like saying, never mind. All right. Delicious dessert. Oh, is there such a thing as a bad dessert? I guess there is.
Yeah.
That's some really sweet sugar. That's silly to say, right? Sugar by definition is sweet. All right, now you're just looking at me like I'm weird. So, what we're going to do, again, -2. I'm going to plug in. These are inputs. I have to plug them in to get the outputs. -2 subtract 2. That's -4. Left 2, down 4. There it is. 0. 0 minus 2 is -2. 0, -2. There it is. 3. 3 minus 2. What's that? 1. 3, 1. So there's the 3 points I can get from my table. But do you see how they would have to go through the other points that I also put on there? Otherwise it wouldn't be a line because it wouldn't be straight. Okay? X, Y here. We'll do the same thing here. Working backwards, you can look. These would be easy for me to work backwards and think through -1, 0, and +1. And if you want to do those 3 every time, that's probably going to be okay. Except maybe in number 3. So, don't you hate it when teachers say that? -1. So again, if I plug in -1 here, -3 times -1 plus 1. Okay, guys, if you're not getting these right, don't try to do this in your head. If you're getting it wrong, do something different. Okay? So -3 times -1 is +3 plus 1 is 4. So the point -1, 4 should be on the graph. Left 1, up 4. There it is. 0 is really easy to do because when 0 multiplies something, it's just 0. So you can kind of cover that up. Well, the answer would be 1. 0 plus 1 is 1 also, by the way. And then the last one, when you plug in +1. So think about it. -3 times +1 plus 1. Well, that would be -3 plus 1. That's -2. So write 1 down 2. There it is. Now, I made that comment about, hey, this would probably work every time, except for maybe number 3. How's number 3 different from 1, 2, and 4?
It has a fraction.
It has a fraction. What is the role of that fraction? What is it doing to the x?
Halving it. Or it's multiplying it.
Yes, it's multiplying. Specifically, just cut it in half. But yes, it's multiplying, okay? Do you guys remember what we called that number? The number that's multiplying the variable? Nope, okay. Coefficient. Okay, it's called a coefficient. Coefficient. You're going to need that. That's vocabulary for next year. The coefficient is a number that multiplies your variable. It's -3 in this problem. It's 5 in this one. What is it in number 1? You don't see a number beside x, do you?
Mm-hmm.
So you have 2 natural guesses. 0 or 1. What do you think? Huh?
Isn't it 1 most of the time?
Most of the time?
Like I understood 1?
Yeah. Have you heard that before?
Yeah.
Here or at a different school?
Well, school taught it.
Briefly. So it is understood. But when something's understood, it doesn't have to be said or written. It's there. The other reason is if it was 0, there wouldn't be an x, would there? Okay? So, very good, very good. So the coefficient here was a whole number. If that one's negative, these two are positive, that's fine, right? But when you get a coefficient that's a fraction, you got to think through, okay, well, I can take half of what types of numbers easier than others. What numbers are easy for you to divide by 2? Even numbers. So when you choose your x's, you should choose evens. It's not wrong if you choose odds. It's just going to give you decimals, okay? So I'm going to choose -4. Maybe I'll choose -0 and +2. Now, -4 is probably not going to give me space, but it'll be all right. So again, 1/2 times -4, subtract 4. That's my first input of -4. What's half of -4? -2. And then I got to subtract 4 additionally. So I got to take 4 more away from -2. I got to move left 4. So actually, it's going to be down 4, right? But I have -2 minus 4. Said another way, they're on the same team. They're going to compound. So that'll be -6. So -4, -6. You can see that was going to be on the graph eventually, right? All right, 0. Remember what I said about 0? Just cover it up, see what's left. -4. There's that point. Okay? And then 2. What's half of 2? 1 minus 4 is -3. 2, -3. Okay, the last one, maybe easier if you think about what we've just done. X, Y. And again, I said it doesn't matter what x's you choose, but these are the only 3 that are going to show up on this graph because it grows so quickly to the right and it decreases so quickly to the left. So -1, 0, and 1 are probably our natural choices here. 5 times -1 is -5. Cover it up, you get 0. 5 times 1 is +5. Okay? So, again, you will study this a lot more next year. You'll study more details about why this graph increases based on the 5 being what it is. Why this graph increases at this rate based on the 1/2. Why it's crossing at -4 when it has a -4 at the end of it. A lot of these are as simple as you're probably thinking right now. Okay, but we don't have to worry about that for our test. What I'm going to expect you to do is make a table and plot 3 points. Questions? Okay. Look at the next page. Now I've done part of this to expedite this process, but I did put some notes up here to remind you of the way we did percentage problems. Percent of a number is another number. I mean, that's just kind of the outplaying of that. Percent means quantity out of 100. Okay, so by definition, 25% is 25 over 100, or 25 out of 100 as a fraction. 100% is a 1. So specifically in this section, because we did percents on the last test, in this section, there was the idea of adding a percent to a number. There was also adding more than 100%, or just the concept of 200% of a number, so to speak. Okay? So understanding that 100% is 100 out of 100, that is a ratio, which means 1. 250% therefore would be 2.5 if you're going to use it in an equation. Okay? So said another way to make sure you guys don't forget this, a percent is a ratio. And if you understand that it's a ratio, then when you want to use it in an equation, you have to write it as a ratio. You don't write it as a percent. Okay, so the percent symbol is not used in calculations. The percent symbol implies decimal, fraction, okay, ratio. So, a couple ways to think about when you add a percent of a number. It implies that 100% of the number that is already there. Okay, so quick real life example. I'm going to fudge the numbers a little bit. Okay, let's say I weigh 200 pounds and I'm going to gain 20% more weight. You don't disregard the 200 pounds that's already there. The 200 pounds is there for you to take 20% of it and then add to, right? So, if you think about what I've got here, 20%, if I add 24% to 10, so, maybe I had a class of 10 students and it grew by 24%. I would add 24% of 10. So you can see there's the add. Or you could consider something. You could consider 1.24 as representing 124% of the original. Okay? 124% is how much more than 100%? Don't overthink that.
24%.
Yeah, it is. So, these are the same thing. These are exactly the same thing. When you add 24% of a number to itself, it's already there, so that's like 100% of itself, right? Okay. What's 51% of 17? What percent of 51 is 17? So I just kind of copied that down from the formula from our book. What percent, that's P, of means multiply, 51 is 17. So you can kind of see what we're going to do here. Now we set it up like one of those one-step equations where we have to, what do we do to solve for P? If they're multiplying, let me make sure that's clear so that you don't think that's a decimal. I'm going to do the opposite. I'm going to divide by 51. So I'm going to get P equals 0.3 repeating. But the question says what percent? So now when I have to take the number and go back to the percent, what do I do?
You do the decimal line.
Yeah. 2 times to change it to a percent. So it would be 33.3 repeating percent. I'm not so concerned about the bar over top, but 45% of 200 is, so again, 45%, how do you find 45% of a number? You convert it to a ratio, 0.45 times 200. You're going to get 90. That's just one you type in the calculator. 170% of 20, we have to understand 170% is 1.7, the number 1.7 times 20. 34. Again, something that we just type in. Okay, 75 is what percent of 25? Hopefully you see what I'm trying to do here. I'm taking these sentences and I'm converting them to algebraic equations directly. Is equals. 75 is what percent? That's a variable of, always turns out to be multiplying. All right? And then we remember, okay, if I'm multiplying two things, one of them is unknown and I know the product, I can go work backwards. I can do the opposite operation. So P equals 3. So it's 3%? Stop and make sure you understand what is going on here. 75 is not 3% of 25. Because the problem asks for a percent, we have to take this ratio number and do what? Jeffrey told me last time, move the decimal twice. So it's 300%. Okay? Check over your answers in that way when you're doing these. Okay? Again, say it in your head. You can't say it out loud, but say it in your head. 75 is 3% of 20? No, that's not right. It's triple. Now, there's a clue right there, isn't there? When you triple something, that's 300%. Okay? Now, number 9 is related to number 8. Number 9 is asking, what is the percent increase from 25 to 75? Or said another way, what percent of 25 do I add to 25? See that? To get 75. So the way I set it up, this is the start. That's what I had originally. And then I'm going to add some percentage of 25, and I'm going to end up with 75. So how would I solve this? What is orange? What does this orange part, the entire value of the orange part, have to be? If 25 plus that gives you 75. Has to be 50. So what we can do is convert this straight to, say, 25p equals 50. So 25 times what number is 50? 2. So is it 2%?
200.
It's 200%. So we have to be very clear about understanding that when it asks for a percent, whatever number you get in the problem is the ratio. Converting it to a percent means you've got to move the decimal. Now let's see if it makes sense. 75 is 300% of 25. 75 is 200% more than 25. So making any sense?
Yeah.
Only saw one head nod. Okay. So numbers 10, 11, and 12 were not completely, I don't think, it didn't say solve, but I'm going to ask you to solve. So 3 less than twice a number. We did take a quiz on this, right? It was like a paper quiz is. 3 less than twice a number. So 3 less than implies start with something else and then take 3 away. Most common error on these, by the way. Start with something else and take 3 away. So you can see how the minus 3 moved to the second half of that left side. Then I want you to solve it. The product of a number and 4, well that's 4n, increased by 12 is 52. Hopefully you're also noticing the easy part to do, the is, that hasn't really changed. Okay, so I want you to take a couple minutes and go ahead and solve 10, 11, and 12. By solve, I mean tell me what the value of n is. All right, so number 10, 2n minus 3 equals 31. These are categorized into a category called two-step equations because they take 2 steps to solve. Okay, those 2 steps were generally, remember that's not every time, but generally add or subtract the constant to the other side, then multiply or divide the coefficient. There's that word again. Okay, so here's my order of steps. Adding or subtracting, we get 34. And then if 2n equals 34, you can kind of think intuitively, double a number is 34, half of 34 has to be 17. Okay, looking at it a different way, the opposite of multiplication is division. So that's what I wrote here. Second one, 4n plus 12 equals 52. Add or subtract to remove the 12. It's going to be subtract. So we get 4n is equal to 40. 4 times n, the opposite of that is divide. Divide by 4, n has to be 10. Questions about the first 2? The last one was a little different. Okay. So, when you look at the last one, 23 decreased by a number is 31. I want you to think, before you even consider what I wrote here, if you can take something away from 23 and the outcome is all of a sudden bigger, what must have happened? If we subtract the negative, the output increases, right? Philosophically, you remove something negative, it's a positive outcome. All right. So, here's what I got. 23 minus n equals 31. So we know it's going to be negative, right? And you do enough of these, you're going to be able to think, okay, well, how far away is 31 from 23? All right, so it grew by 8. And if you think what Ezra said, I must have subtracted the negative, it had to be negative 8. But how do we show that with our steps? How do we show that with our steps? So if you look at 23 minus n equals 31, 23 is the constant. What kind of 23 do you see in black, the original?
Positive.
It is positive. The opposite of positive 23 is subtract. So we're going to subtract 23 from both sides. We've got to do it from both sides to stay balanced. And then I stopped because I wanted you to think about something. This is going to cancel out. That's what we wanted. 31 minus 23, hey, that's 8. You told me that already. What's left on the left side?
N?
No. What was happening to n?
So then subtraction.
It was being subtracted from 23. And if you took the 23 away, there's really a 0 there, right?
Right.
So 0 minus n is the definition of negative n. That n is kind of attached to that subtraction in front of it. All terms in an equation, the sign that's in front, it identifies like what kind of n that is, okay? So the opposite of n is 8, therefore we can say n is equal to negative 8. Thinking about it one last way, and then I'll let Jeffrey go to the bathroom. What's the coefficient here? What's the coefficient on this n?
So negative.
Negative what? 1. Okay, so it's understood. There's no number there. It's an understood 1. Now, if you realize it's negative 1 that's multiplying, we're going to do the opposite, which will get rid of it. We're going to divide by negative 1. Divide by negative 1. 8 divided by negative 1 produces that negative 8. Okay? Shoo. All right. So, proportions, ratios and proportions. So, you don't have to find the unit rate unless I ask you for it. But these are pretty pretty straightforward. You're given one ratio. You should write your mystery ratio, it's going to be missing one term, in the same order. So my particular one says awards over years. So whatever I write over here has to be awards over years. Set them equal to each other and cross multiply. That is the method we have used to solve a proportion. So we're going to get 17t equals 153. What do we do to solve that? We're going to divide by 17 on both sides, and we're going to get t equals 9.
Yeah.
Okay. Now, some of you, many of you, I would imagine, can probably tell me that that's 9 without doing this. You can look, well, 17 times some number was 51. So really, when you're dealing with a proportion, one side is just a scaled up or down version of the other side. So the fraction 17 over 3 has an equivalent fraction 51 over 9. Thinking about it that way, 3 times 3, that gives you 9. 17 times 3 gives you 51. They're just equivalent fractions. One of the numbers was just unknown. Okay? Let's see if we can apply that to number 14. A barbell started to chip as we dropped it onto the floor repeatedly. Must not have been a bumper plate. I weighed the first piece it chipped off and it was 2.7 pounds. This represented equals 2/21 of the whole plate. So how much did the original plate weigh? So 2.7 out of the whole is equivalent to 2/21. Okay, so you see how that's almost identical to number 13. We're going to cross multiply. I'm going to say 2w equals, I don't know if I can do that in my head, 21 times 2.7. Everybody get that on the paper? 56.7. So we'll do what to solve for w? We're going to divide by 2. 28.35 pounds. All right. Now on to the last topic in here. Surface area and volume. Lateral surface area would mean like the sides, right? But surface area and volume require us to understand how do we do that in different cases, especially when you have rounded surfaces. So remember I said you should probably make some flashcards. There's a couple that I would add to this. The volume of a cylinder. You remember what that was? Pi r squared h. All right, but anyways, they're asking for surface area number 15. So, surface area of a half cylinder with a diameter of 12 millimeters and a height of 20 millimeters. So the first thing I'm going to try and do is just sketch it out. Okay? So here's my half cylinder. I'm going to do it like that. Got this going on. Okay? The diameter is 12. So if the diameter is 12, what value can we take from that to use? Especially if we're talking about area, we need the radius. So we need to understand, therefore the radius would be 6. Okay? And they also tell us the height is 20. Do we need anything else?
You would need the radius of the height, wouldn't you? Would you need the radius of the height?
What do you mean the radius? The height is 20. Height is 20. So that's this one, yeah. That's that measurement here. So what shapes do we have?
A square and a semicircle.
Was it a square?
Or,
How do you know? Could be a square. Why isn't it a square? All right, so if I draw it, I'm going to have a 12 by 20 rectangle for that front. So that'll be 240 square millimeters. Check. How many other surfaces do I have? If I've got the face here, I've got the top and bottom, which are both semicircles. 2 half circles combine to make a single whole circle. Okay, so I can just find the area of a circle with a radius of 6. Pi times 6 squared. So 36 pi, or What is that? 36 pi. If we just use 3.14, okay, no, can't keep up, calculator. 113.04 millimeters squared. So I'm going to add that to it. Plus, now I have the last part, and this is, I saved the tricky part for last. This, what wraps around the back side of this half cylinder? It's also a rectangle, correct? A rectangle that is 20 millimeters tall. That part's not so bad. But how long is it? So I'd be looking for, should have saved this color, this distance here. So what does that represent? That represents half the circumference. Half the circumference, and circumference equals 2 pi r. So if we have to divide that by 2, what does it become? Pi r. So r is 6 pi, or I'm sorry, r is 6, so we have 6 pi. So then I have to multiply one more time. 6 times 3.14, 18.84 times 20. We're going to get 376.8 square millimeters. Don't you love it when I make up the problems?
No.
That was rhetorical. I know you don't. 240 plus 113.04 plus 376.8. So we're getting 729.84 millimeters squared. Anybody get that? All right, so let's see if we can draw 16. I heard there was some trouble with this one. So semicircular section is attached at both ends of a rectangular box. Okay, so let's draw the box. Okay. Man, that's a bad box. Semicircular section, half cylinder. All right, so let's draw the half cylinder here in a different color. It's added to both sides, okay? So that's kind of what it looks like. It doesn't hang down like that, but you guys get the picture. The radius is 12 feet. So the radius, R equals 12 feet. The box is 18 feet long, 18, and 6 feet tall. Find the total surface area. So if you can do 15, then you're going to need that skill to help you with number 16. First question to ask: Did you get the picture right? So by saying that the radius is 12, that implies the box is actually 24 feet wide. So I mean, it's not to scale. Please don't think it's to scale. So the surface area would just be adding up all of the faces that you can see. And I would prefer to have more space and more time, considering I've only got a minute left. So is it okay with you guys if I post the answer to this a little more clearly once you get the picture drawn?